Welcome back to Geometry, Chapter 11, Section 4, Circumference and Arc Length. Now, remember way back when we were talking about Pac-Man? And we said that the degree measurement of this angle in his mouth is equal to the arc length right there of what's missing in his mouth. And remember that I told you that those were measured in degrees. But later we would talk about what if they were measured in length. Because we could also put a little string right here and measure how in inches, meters, centimeters, how long that little red line is, couldn't it? So we can measure it two ways. And it turns out there's a relationship between those, measuring it in length and measuring it in degrees. And to me, this is one of the easy, logical parts of geometry. But before we get there, let's review. So remember, in a circle, a round shape's a circle, a line from the center to the edge is called the radius. If you go all the way across through the center is the diameter, and diameter is two radii, radiuses, radii. And if you go all the way around a circle, the length going all the way around is called the circumference. Now we have a couple of formulas for circumference. You can say it's pi times diameter or 2 pi times the radius. Where does this pi come from? When I taught public school, I used to keep a little piece of red yarn in my desk just for this explanation. And that's why radius is in red. I'd take the little red piece of yarn and lay it on the radius so they were the same length. And then I would lay it around the circle and it would go 1, 2, 3.14159, dot, dot, dot. That's where pi comes from. It's how many times a radius can be laid around half a circle. So if you go around the whole circle, then that would be the circumference, and it's 2 pi times the radius. So I like this formula better. That's why it's got the square box around it, because I can remember it, because I know where pi comes from. It's how many times you can lay the radius around half a circle, and then 2 pi would be how many times you could lay it around the whole circle, and that's the circumference. To me, that's the logical one. That one I can figure out, but that's the one it is in my brain. So if you want your brain to have the same one, that's the one I use. All right, next idea. So here I have a little sample problem, and I'm told that once the circumference and the radius is 6. So I put it in this formula. Circumference equals 2 pi radius, circumference equals 2 pi 6. What's considered the correct answer is 12 pi, but nobody knows what that is. So we always say, which is approximately equal to 37.7. Oh, I guess that's not 6. My handwriting's kind of bad. All right, here's another one. This one, the circumference is 31, and they say, what's the radius? Well, I go back to this formula and substitute 31 in for C, and then I solve for radius. So why is radius not a line? It's being multiplied by 2 and a pi, so I divide by 2 and a pi. And notice that I don't have to do those one at a time. I can do them all at once. These cancel out, and you're left with 31 over 2 pi, which is actually considered the correct answer, but that's approximately 4.93. Okay, here's a few more things to remember. A semicircle is half a circle. It's 180 degrees. So it would be 2 pi r divided by 2. And if you have just one quadrant of a circle, like that one, it's 90 degrees, and it is 2 pi r over 4 for the circumference. This, not important. You can always figure that out. Not important to memorize. All right, now this is important. So here, this is the thing I was telling you about, the relationship between the arc and the degrees of the circle. So arcs can be measured in length, like meters and inches, or it can be measured in degrees. The circumference of a circle is a length measurement, but if you go all the way around a circle in degrees, it's 360. So we have this relationship, this ratio that relates these. If you measure the arc in units of length, meters, inches, and divide it by circumference in units of length. And circumference is 2 pi times the radius. That is a ratio with, it's equal to the measure of the arc in degrees over 360 all around the circle. So circumference is all the way around the circle. Degrees is 360 is all around the circle. This is the little measurement of the arc this way in inches or whatever, and this is the measurement of the arc in degrees. And remember that whatever degrees this is the same as that, because it's Pac-Man and not Roly-Poly-Oly's grandpa. All right? Do you want me to sing that song? No, well, I don't think we have time. Oh yeah, we do. Roly-Poly-Oly, he's short and square and round. Okay, so let's do some problems. Here, the first time they asked for arc length, we have in degrees, and we have the radius, and we know this degrees is also that degrees. Okay, so the thing we're missing is arc length, so that's our x. Our denominator is 2 pi times the radius. Our radius is 5. Our degrees of our arc is 50, that goes there, and 360 here. We cross multiply and solve for x. So it's going to be 50 times 2 times pi times 5 divided by 360, and you get 4.36. You should be good at solving for cross multiplying and solving for x now, so I'm not going to do it for you. You do it on your calculator if you need practice. You'll get it. Okay, so here's another one. This one, we are given that the radius is 7 and the arc is 50. If the angle is 50, so the arc is 50. So cross multiply and solve for x, and you'll get x equals 6.11. Okay, how about this one? This time they want the circumference. They gave us the degrees and the arc length in meters, but they didn't give us the radius. Okay, so that's what we're missing here. The radius right there in the circumference. Okay, and they're asking for circumference. So what we can solve for it by putting c there for circumference, because notice that 2 pi r is circumference, so that's our unknown circumference, and we can just put a c. We don't have to solve for the radius then get it, we can just solve for it. So cross multiply, solve for x. I love cross multiply, solve for x. Okay, here's another one. This time we have the measure of the arc in length is 18 inches. We have the radius, but we don't have any degrees. So what we need is the degrees. So always be real careful to identify your knowns and unknowns. Make sure you're solving for the right x. So we put in our length, we put in our 2 pi radius, we put in 360, we cross multiply, here's my cross multiplying, and notice how I divided it all at once. It was very exciting, and got 135 degrees. So that would have been here and here. Degrees. Ta-da! I think these are super fun. To me, they're extremely logical and easy. I love them. I hope you do too. Come back next time and we'll learn more geometry. Math is great.